Hello everyone. Today we'll be discussing about a topic named flotation. So, we all are very aware of a phenomena which exists when we take a container, we immerse an object inside the container and we fill the container with liquid, any liquid. So what happens here is when the body is immersed in liquid, two forces act on the body. Okay, the first force, which is called weight, which is denoted by W, it acts vertically downwards. Okay, this weight acts vertically downwards through the center of gravity G. Now this is called G, center of gravity G. Okay, so what we saw, when a body is immersed in a liquid in a container, two forces act on that body. The first force is called as the weight and it acts vertically downwards through the center of gravity G of the body. Now this force has a tendency to sink the body. This was the first force. Now the second force that acts on the body, which is immersed in a liquid in a container, is called as upthrust. Upthrust or buoyant force, which is denoted by Fb. Okay, now this upthrust of the liquid, which acts vertically upwards to the center of buoyancy called as B. This is also the same point which we denoted for the gravity, the center of gravity G. And this FB acts vertically upwards. Okay, and now this force is called as buoyant force or upthrust, and it has a tendency to make the body float. Okay, so we are aware of when we are clear about this. So now if we have to write formulas for the further part, what we will see is the formulas of W. Okay, the formula of W is volume of the body multiplied by density of the body multiplied by acceleration due to gravity. This is the formula for weight, and the formula for upthrust is equal to volume of submerged part of the body. This was volume of the body, whole body is volume of the submerged part of the body multiplied by density of liquid multiplied by acceleration due to gravity. Okay, so these are the two formulas that we have to keep in mind. Now depending upon whether the upthrust, this upthrust buoyant force, is less than, equal to, or greater than the weight of the body will either sink or float in the liquid. So we consider three cases. Okay, now the first case that we are considering is when W is greater than Fb, that is the weight of the body is greater than the weight of the displacement. So what happens in this case is, if we take a container and if we take a body, so this is the weight, this is the buoyant force, here is G, here is B. So what happens when W is greater than Fb? In this case the body will sink. Okay, and this is the case when the density of solid is greater than the density of liquid, because in W we know that according to the formula, this in W we take rho B. So if W is greater than Fb, then W, it corresponds, rho B is greater than rho L. Okay, this is the first case. Now if we go to the second case, it is of when W is equal to Fb, that is the weight of the body is equal to the buoyant force. Again, if we draw, this is a container and this is the liquid. So in this case what happens is, the object will float, just below the surface of water, just below the surface of water. Now this case exists only when the weight of the body is equal to the displaced liquid. Okay, now in this case the rho B is equal to rho L. Okay, here also W is B, and yeah, here is G, and here is B. Okay, now if we have to see the third case, in the third case W is less than FB. Okay, so what we can say is that the weight of the body is less than the weight of the liquid dispersed. So in this case, if we have to draw a diagram, it will go like this. We have to draw the liquid first, and what will happen is this is the case. G, B, W, F, B. What happens in this case is that the body will float partially. See, it's floating partially. Half is below the liquid and half is above the liquid. Only that much portion of the body is submerged, by which the weight of displaced liquid becomes equal to the weight of the body. Okay, and now in this the rho B is less than rho L. Okay, so here we have concluded these three cases. Now from this we have to define the principle of flotation. So what is the principle of flotation? I'll just write it is W is equal to FB. When W is equal to FB, then we can say that the flotation exists, which is our second case. This. Now what if we have to define, then we'll say as according to the principle of flotation, the weight of a floating body is equal to the weight of the liquid displaced by its submerged part.